Hello and welcome to this video tutorial. In this video, we're going to be going over skills practice 5.2 equilibrium. Please remember to pause or rewind the video as you need to. Let's begin. Read along with me, please. When all forces acting on a body are balanced, the forces are said to be in equilibrium. So here's what we're going to do. We're going to be taking a look at essentially forces acting on opposite sides of an object. And what we're basically trying to do is make the forces balance. Okay, so the forces are going to seem unbalanced at first. Okay, here's an example. You can see that there is 600 newtons pushing down on this rectangle, this object here. You can see there's 400 newtons pushing up on it. Now, you're supposed to have the same amount of force pushing up and down for them to be balanced, but clearly they're not yet balanced. So what must this force be in order for the bottom force pushing up to equal the force on top pushing down? Well, if this is 600 and this is 400, that means this leftover force has to be 200 newtons. Okay, and that's, you can see what they get right here when we do this. So that's essentially what we're going to be practicing, is we're going to be practicing taking a look at how to balance our forces. Okay, let's go ahead and begin. Number one. What I see in number one is I see a table that has an object on it. Now there's a 400 Newton force acting on the table and a 96 Newton force acting on the object. So the total force acting down is 496. Okay, so what am I looking for? Well, I'm looking for this thing called, I'm going to call it F right here. Okay, go ahead and label this as F. That's kind of what I'm looking for. I'm looking for F. Now, I'm going to split my given box into two parts. Forces that are pointing down and forces that are pointing up. And I want to make sure these are completely balanced, okay? So forces pointing down would be 496. So 400 newtons, 96 newtons. And if I were to add those two, I would get 496 newtons going down. Now going up, I see three forces, these three here in particular. I see 142, I see 106, and I see 106. Okay, let's add those up. 142 plus 106 plus 106 is 354 newtons. So I can see that if I have 496 pushing down and 354 pushing up, the remaining force, the missing force on the fourth leg, has to be the difference between those two. And that's exactly how we're going to find these missing forces. The relationship that we'd use here, a generic relationship, would be your forces pointing up equal and balance your forces pointing down. Okay, and to make them equal, I've got 496 down, 396 up, so it's going to be 496, whoops, 496 equals 354 plus F, because that's our missing force right there. Okay, go ahead and solve for F. We would do that, of course, by subtracting 354 from both sides. And you can see that the missing F would be the difference between those two, 496 minus 354, which is another 142 Newton force. Question 2, supply the missing force. Now you'll see that there's a total of 5 forces pushing on the right of the object and 3 forces pushing, 5 forces pushing on the left of the object towards the right, and 3 forces that are pushing on the object on the right side pushing left. So what we want to be able to do is we want to be able to figure out, let me see. Now we're going to assume that this force here and this force here are going to be the same amount of force, because otherwise we'd have very little way of figuring out if they were different amounts. We'd need a second equation to help with that. So with one equation, we're going to make a giant assumption that I'm going to call this FA and FB. So we're looking for FA, which is equal to FB, which are both of our question marks, okay? Now, this time we have forces going to the left and force going to the right, not up and down. So I'm going to examine all the left forces, which I'm going to abbreviate LT, and all the right forces, which I'm going to abbreviate RT. So the left forces, we have 25 newtons, we have 10 newtons, and we have another 25 newtons, okay? All of those, of course, add up to 60 newtons going to the left. Going to the right, we've got 75 newtons, you've got 10 newtons, and you've got another 75 newtons. Now, 75 plus 75 is 150, plus 10 would be 160. So we're going to be looking at forces left equal forces right to balance off the forces in this particular problem. And so forces left, okay, we would have force, let me see, let's see, 4, so 60 plus F plus F. And both of those F's represent those two missing forces right there. Right here and right here. And they're going to equal 160 going to the right. Or going left, rather. Okay, and so we're going to clean this up a little bit. So 60 plus 2F equals 160. Let's go ahead and solve this equation for F. We'll subtract the 60. And we have 2F equals 100. Go ahead and divide by 2. And each force, force A and force B, both equal 50 newtons. And finally, question 3, distribute the unknown forces evenly to prevent rotation. So in order to prevent rotation, up has to equal down and right has to equal left. So we're going to need both equations. Force left equals force to the right, and force up equals force down. Okay, what am I looking for? Well, I'm looking for force A, which is equal to force B. That's my first question mark, would be those two there. And then force C, which is this one pushing up right there. Okay, so we're looking for this one, and this one. Okay, so what I'm going to do is I'm going to divide these up into 4 different segments. So I've got, there we go, I've got up and down. So up, down. Okay, then I've got right and left. Okay, so up and down. Let's start with up and down. So down, you can see I've got 2 forces pointing down, 20 newtons and 100 newtons. Adding those together, we get 120 newtons down. Up, we have 112 newtons pointing up. Okay, so go to my solution box, we'll split it in half because we're going to be focusing on 2 things. So vertical forces, so force up equals force down. We're going to start there. Okay, force going up would be 112 newtons plus Fc. So F plus 112 newtons would equal the 120 going down. Go ahead and solve for Fc and subtract the 112. And we get that Fc is equal to 8 newtons. Okay, now right versus left, you can see we've got 10 newtons pointing to the right, and then plus A plus B. And pointing to the left, you've got 25 newtons, and you've got 25 newtons, which of course add up to 50 newtons. And so here's what we have. We have F plus F, that would be FA plus FB, plus 10, those are all the forces pushing to the right, equal the total force pushing to the left, which is 50. Cleaning this up a little bit, we get 2F, F plus F is 2F, plus 10 equals 50. Go ahead and subtract the 10, and then rewrite this. We get 2F equals 40, and then go ahead and divide both sides by 2. And FA would be equal to FB, which both would be equal to 20 newtons. I hope you found this video tutorial helpful. Please remember to pause or rewind as you need to.